Welcome to the deep dive. Today we're diving into something huge. Generative AI or Gen AI. The speed it's being adopted is just wow.
It really is astonishing. And the scale,
Yeah.
we're looking at projections, like from Bloomberg, suggesting a potential $1.3 trillion market by 2032.
$1 trillion. That's massive. But with that speed and scale comes, well, a pretty significant problem, doesn't it?
Exactly. That's the urgency here. These large language models, LLMs, they learn from vast amounts of internet data. And that data, it's full of our existing societal biases.
So the models just soak them up.
They reflect them, and sometimes they even amplify them. It's baked in, you could say.
Which means our usual ways of governing tech, our current data rules, they might not be up to scratch for something this complex, this pervasive.
They're really not sufficient. High-level principles are one thing, but Gen AI needs something more specific, more granular.
So our mission today is to get practical. We want to move past just talking about ethics in the abstract and really explore what a systematic governance framework looks like for these LLMs.
That's right. We'll be looking at how organizations can actually implement this stuff, building on foundational work like the BEATS framework. That's the Bias Evaluation and Assessment Test Suite. Yeah. The goal is equity, fairness, ethics throughout the whole LLM lifecycle.
From start to finish.
Exactly. Making responsible AI something you do, not just something you talk about.
And for you listening, whether you're on the compliance side or maybe you're building these things, we're aiming to give you concrete methods, ways to manage the very real risks involved.
Because the risks are real, especially when these systems start making decisions in critical areas.
Like, what kind of areas are we most concerned about?
Think about healthcare, finance, legal services. If an LLM is helping decide who gets a loan or suggesting medical treatments or even assisting in legal discovery,
And it's carrying inherent biases.
the potential for harm is substantial. It's not theoretical anymore.
Let's maybe unpack that term bias a bit more. What kinds are we seeing in LLMs?
Oh, it's multidimensional.
Yeah.
Seriously. Our sources list things like gender, race, ethnicity, socioeconomic status. Also culture, religion, sexual orientation, disability status, age, even geography and political ideology, and just general stereotypes,
So basically all the complex, messy ways humans categorize and unfortunately discriminate against each other.
It's a reflection amplified. And we have hard data on this now, thanks to frameworks like BEATS.
Ah, yes, beats. What did that find specifically?
The results were pretty startling. They tested leading industry LLMs and found that 37.65% of the outputs showed some kind of bias.
Wow, nearly 4 out of every 10 responses.
Yeah. Imagine that on another field. Like if your accounting software was wrong almost 40% of the time.
You'd pull it immediately. No question. It's an unacceptable error rate for anything critical.
And it's not just the frequency, it's the severity too. The BEATS analysis found that about a third, 33.7% specifically, of those biased responses were rated as having medium or high severity.
Meaning they weren't just slightly off, they could actually cause significant harm.
Precisely. We're talking deeply embedded stereotypes, cultural prejudices. The analysis showed that global and cultural biases and socioeconomic ones were particularly common in those high-severity cases.
This shouldn't be a total shock, though, right? I mean, hasn't AI bias been a known issue for a while?
Absolutely. You can go back to, 2016, that seminal work by Buzzik-Bossi and his colleagues on word embeddings.
The building blocks of language understanding for these models?
Exactly. They showed even then how models trained on internet text picked up and even amplified stereotypes. The classic example was man is to computer programmer as woman is to homemaker.
Right, I remember that. It really highlighted how the foundational data was already skewed.
And that was years ago with simpler models. Now we have much more complex generative systems built on similar, if not more, data. So the problem persists and regulation is trying to catch up.
Which brings us to the regulatory landscape. It sounds like a minefield. How are regulators trying to tackle this?
We can kind of break down the global efforts into 5 main pillars of focus for AI regulation.
Okay, what are they?
First, and maybe most established, is data privacy and security. Think GDPR in Europe, CCPA in California.
Standard stuff, mostly.
Well, yes and no. You also have newer, sometimes stricter laws popping up everywhere. China's PIPL, Russia's data localization laws, which are very demanding, India's recent DPDPA. It gets complicated fast.
Just managing the data location rules alone sounds like a nightmare for a global company. If Russia says data has to stay in Russia, how do you train a global model effectively?
It's a huge challenge for scalability. Definitely hinders cross-border innovation. So that's pillar 1. Pillar 2 is fairness and non-discrimination.
This feels like the core issue for LLMs.
It is. You have existing laws like the Equal Credit Opportunity Act in the U.S. and upcoming things like the EU's AI Act, which proposes strict rules for high-risk AI systems, demanding they are free from bias.
But wait, you just said the models are trained on biased data. How can they be free from bias? That seems like a contradiction.
It's a fundamental tension. That's one of the key implementation gaps we see. The regulations say, be fair, but the data says, reflect society's unfairness.
Okay, so that's a big one. What are the other pillars?
Pillars 3 and 4 are closely related: explainability and transparency. Regulators want to know how AI makes decisions, especially important ones.
The black box problem.
Exactly. And Pillar 5, which sometimes gets less attention but is increasingly important, is environmental sustainability, pushing for energy-efficient AI development and deployment, referenced in things like the EU Energy Efficiency Directive or ISO standards.
So 5 pillars: privacy, security, fairness, explainability, transparency, and sustainability. Sounds comprehensive, but where does it break down with Gen AI specifically?
2 major sticking points, really. First is that data versus fairness conflict we just touched on. How do you comply with non-discrimination mandates using inherently biased internet data? It's tough without major intervention.
Right. And the second?
The second is that black box versus explainability issue. Financial regulators, like the Basel Committee, demand models be auditable. You need to be able to understand why a model made a certain decision.
But with Gen AI?
With Gen AI, tracing a specific output, say a complex paragraph of text, back to the specific inputs or training data points that caused it, it's incredibly difficult, sometimes impossible.
So the rules tell us what ethical AI should look like, but they don't really give organizations the tools or the how-to for actually achieving it with these complex generative models.
That nails it.
Yeah.
And that's precisely why a more systematic lifecycle approach to governance is needed. Something built for AI, not just applied to it.
Okay, let's walk through that life cycle. If we're building this governance framework, where does it start? Data acquisition.
Absolutely. Phase 1, data acquisition and pre-processing. You have to be proactive here. It starts with really scrutinizing your data sources. Where is it coming from? Is it diverse? Is it representative?
How practical is that, though? We're talking petabytes of data sometimes. Auditing all of it for demographic diversity sounds expensive.
It is resource intensive, no doubt.
Yeah.
But the potential cost of not doing it, the fines, the reputational damage, the harm caused by biased outputs, is increasingly seen as much higher.
A necessary investment, then.
Yes. And it's not just the raw data, it's also about the labeling process.
Yeah.
Who is labeling the data? What guidelines are they using? You need transparency there, standardized protocols, and ideally, diverse teams doing the labeling to catch biases early.
Right. Avoid embedding subjective views right at the start. Okay, so you've done your best to get cleaner, more representative data.
Yeah.
What's next? Phase 2, model development.
Exactly. Model development and validation. This is where technical solutions meet organizational oversight.
How so?
Technically, you can choose algorithms designed with fairness in mind. There are fairness-aware machine learning techniques. Organizationally, this is where you need things like independent ethics review boards.
Like an internal watchdog.
Sort of. And formal fairness impact assessments. Before a model gets anywhere near deployment, it has to pass these ethical checks. It forces documentation and justification.
And this is where explainable AI, XAI, comes in, right? To crack open that black box.
Precisely. XAI techniques are crucial here. The framework uses specific tools. You mentioned A-Shape and Lime earlier.
Right, Shape and Lime, catchy names. What do they actually let engineers do? How do they help explain things?
Think of it like getting an ingredient list for the model's decision. SAP, that's Shapley additive explanations, helps calculate how much each piece of input data, like someone's income or location, contributed to the final output.
So you can see which factors were most influential.
Exactly, it points to the why. Lime local interpretable model agnostic explanations does something similar, but focuses on explaining one specific prediction at a time. Why this loan application was denied, for instance.
Okay, that provides some much-needed transparency. Are there other tools involved?
Yes. Things like partial dependence plots, or PDPs, help visualize how changing one input feature affects the model's predictions overall. And counterfactual explanations explore what-if scenarios, like what's the minimum change needed to flip a decision from reject to approve?
So you're constantly probing the model, testing its fairness.
Constantly. Evaluating against specific fairness metrics, comparing performance across different demographic groups. If the model performs significantly worse for one group versus another, it fails validation. It doesn't proceed.
This sounds robust for development, But the real test is in production, isn't it? When it's live, interacting with users. How does governance work there in real time?
That's phase 3, real-time guardrails in production. It starts with deployment gatekeeping.
Meaning,
Before any new model version goes live, it gets evaluated using those bias frameworks like beats. It receives a RIG score.
and there's a threshold.
Yes. If the model's bias score is too high, meaning it falls below a predefined acceptance threshold, deployment is blocked. Simple as that.
What happens then? Back to the drawing board.
It triggers a mandatory retraining process, often involving a review of the data curation or even the model architecture itself. Only models that score above the threshold get the green light for deployment.
Okay, so a good model gets deployed. But even good models can sometimes produce bad outputs, right? How do you catch those in the moment before they reach a user?
This is the really crucial operational piece, the adaptive retry mechanism. It relies on continuous fairness monitoring.
So systems are watching the output live.
Yes, real-time dashboards and automated checks are assessing the outputs as they're generated using similar bias detection logic.
Okay, let's play this out. I ask the LLM a question. It generates an answer. The monitoring system flags that answer instantly as high risk or biased. What happens next?
The system acts like an immediate circuit breaker. That high-risk response, the one that fell below the fairness threshold in production, is stopped. It doesn't get sent to you, the end user.
Okay, it stops the bad answer, but what does the user see? An error message. Does it just hang? That could be a bad experience.
That's where the adaptive retry part comes in. It's designed to minimize disruption while maximizing safety. Instead of just blocking, the system immediately triggers a retry.
It forces the model to try again.
Exactly. But not just try again blindly. The retry mechanism often includes additional prompt instructions, sometimes called guardrail prompts, specifically telling the model to generate a response that avoids the detected bias or adheres more closely to ethical guidelines.
Ah, so it nudges the model in a better direction for the second attempt.
Precisely. It's an automated way to intercept potential harm in real time, forcing a safer, fairer output.
And I assume this isn't just a one-off fix. Does this failed attempt get logged somewhere?
Absolutely. That's the final piece.
Yeah.
The feedback loop. All this monitoring, the blocked responses, the successful retries, it all feeds back into the system.
It drives continuous improvement. The data on what kinds of prompts or context trigger biased responses is incredibly valuable for retraining, fine-tuning the model, perhaps using reinforcement learning techniques to specifically penalize biased outputs. The model gets better over time because it's learning from its real-world mistakes.
So what we've outlined is really an end-to-end system. It starts with cleaner data, builds in ethical checks during development, sets a quality bar for deployment, and then uses real-time monitoring and intervention in production, all feeding back to make the model continuously better.
That's the idea. It's a structured way to bridge that gap between the high-level regulatory demands, be fair, be transparent, and the practical realities of managing these incredibly complex GenAI systems.
And the value for an organization is, well, compliance, obviously, with rules like GDPR or the EU's Data Governance Act.
Yes, compliance is huge, but it's also about mitigating that massive reputational risk. Remember the nearly 40% bias rate. Deploying systems like that unchecked is just asking for trouble. This framework provides a way to manage that risk proactively.
It feels like a necessary step towards actually trusting these powerful tools. But is it perfect? As we wrap up, are there limitations we need to consider?
There is one critical limitation, or perhaps a future challenge, that we absolutely need to highlight. It relates to how we're measuring bias in the first place.
With frameworks like Beats, what's the issue?
Well, often these evaluation frameworks, like Beats, actually use another LLM to act as the judge of fairness for the LLM being tested.
Okay. An AI judging an AI.
Right. And the problem is the judge LLM and the LLM being judged are often trained on similar data sets. And those data sets, as we've discussed, are predominantly English language and reflect primarily Western cultural norms and perspectives.
Ah, I see where this is going. If the judge only understands fairness from one cultural perspective.
It risks creating a self-reinforcing loop or an echo chamber. The evaluation scores might show fairness, but it's fairness defined through a potentially narrow cultural lens.
So the system might inadvertently filter out or penalize outputs that are perfectly acceptable or even considered fair in other cultural contexts.
That's the risk. We might be optimizing for a definition of ethical alignment that isn't truly global, potentially marginalizing non-dominant viewpoints or cultural nuances.
Which leaves us with a pretty profound challenge, doesn't it? As this technology becomes a $1.3 trillion global phenomenon, How do we ensure our governance frameworks, our very definition of fairness, evolves to be genuinely inclusive and respectful of diverse global perspectives? How do we stop one cultural standard from becoming the default for the entire world's AI?
That is the critical question for the next stage of AI governance, ensuring our quest for ethical AI doesn't inadvertently embed a new form of cultural bias at a global scale.
A crucial thought to leave our listeners with. Thank you. This has been an incredibly insightful deep dive.
My pleasure. It's a complex but vital conversation to be having.